Warm-up problems from today's class. We discussed the proportion method for solving percentage type problems and simply started out with the idea that when we have a relationship that we define the left-hand side as some number per 100, and recall that is the definition of percent. A number per 100 is the definition of percent. If you then have other values, some other amount compared to some other amount, and set them up in a ratio form, then if these are unknowns, any one of these are unknown, then you can use cross multiplying to solve for it. The nice thing about the percentage proportion setup is that this is always going to be 100. And so in these problems, you will either be solving for N or A or B. So the general form is N over 100. That's an N, not an M. N over 100 equals A over B. This is amount. This is base. Previously, we had discussed the percentage calculation method using the calculation formula of the amount is equal to the percent multiplied times the base. And so we had some examples where if you have some number over 100 compared to 90 out of 100, obviously you're going to get 90, right? 90, and so therefore 90 over 100 is 90%. Some number over 100 compared to 50 out of 60, do the calculations and you get that the corresponding number here is 83.3, or this is 83.3%. Similarly down here, same kind of calculation. How am I doing this? Well, I'm simply multiplying and solving an equation. So I multiplied N times 60 and got 60N, 100 times 50 and got 50,000, divide both sides by 60 and you get those results. Now, you might recall that in a previous class, we used these problems and we used the percent formula to help us with the solution. Notice this was the problem where we had a test that had 100 questions, a test that had 100 questions, and the student had 90 correct. And so that one was easy, right? 90 out of 100 is 90%. So here's the same setup. 90 out of 100 is 90%. Here's the one where we had a question that had test that had 60 questions. You got 50 of them right. Number out of 100 related to 50 out of 60. 60 question total, 50 right. Do your cross multiplication and you get 83.3%, which is the same value we received here. This problem was the recliner discount problem, where a recliner listed for $250 on sale at a price that was reduced by $20. What is the percent reduction? So here's the problem. N over 100, looking for the N value or percent. This is the original value, the $250. Let me get this out of the way so you can see this. This is the N over 100. This is the original value, and this is the discount amount or price reduction amount. So we're wondering what is the percentage of 250 represented by 20? Do your cross multiplying and you get 8%. You'll recall that when we did this problem before, we used the equation. Amount equals percent times base. The amount was 20, looking for the percent. The base was 250, and yes, we got 8% again. I will point out that this calculation with the equation gives you a decimal value that you have to convert to a percent, while the proportion method directly produces your N value, which is the value of 8 per 100, and it directly gives you the percent without having to do any decimal manipulations. We had some other problems that were similar to the ones that we had done the other day when we used the recliner example. This was the one where we had recliner originally priced $250 was reduced by 10%. All right, so we did that one. Okay, so original price was $250. reduced by 10%, what was the amount of the reduction? $25. You could probably gotten that one more directly. You could just said what 10% of 250 is 25, but using the ratio and proportion method gives you this. The one question that we didn't answer the other day was for this above situation where it was originally 250 and was reduced by 20, the new price is 230. So the question was, what percent of the original price is 230? So now we're going to solve for the percent number in original price was 250, new price was 230. So what percent of the original price is the 230? Well, it's 92%. Now that shouldn't surprise you, should it? If it was reduced by 8%, think that through, reduced by 8%, therefore the new price must be 92% of the original price. Does that make sense? If I take 92% and add 8%, I get 100%, and I come back to what the original price of $250 was. Now, here was a problem where we had a recliner that was reduced by 12% of the original price. The dollar amount of the reduction is $30. Well, what was the original price? What did they tell me? They said that the original price, I don't know. I don't know what the original price was. I know that the percent reduction was 12%, and that 12% was $30. So 12% of this original price is $30. And so how would you solve this one? 12 times B is 12B, 100 times 30 is 3,000. You divide it out and you get that the original price was $250. Now, the next question we could ask ourselves is, how can I kind of verify that the new price is in fact $220? Because that's what I think it is. Okay, the original price was $250, reduced by $30. So the new price is going to be $220, and the original price was going to be $250. So if you take the original price and reduce it by the $220, we do in fact get $30. And if you take that the original price was 100% of the price and reduce it by 12%, you get 88% as being the percent that 220 is of 250. If I multiply 88% times 250, I should get 220 if we did all this correctly. So if we take and say that the new price is $220. That's what we just said. We said the new price is $220. And we think the original price was $250. So if the original price was $250 times a 12% reduction, that would be $30 for the reduced price. $30 would be the amount of the reduction. So 250 minus 30 would in fact be the 220. If I say to myself, well, 220 divided by 250 is in fact, oops, I'm thinking something wrong here. Let me do this again. 220 divided by 250 is, okay, I'm not looking at what I'm doing. Let me do it again. 250 divided by 220 is in fact, did it wrong, didn't we? 220 divided by 250. Did you catch that? So the new price is in fact 88% of the old price. So $220 is a new price, which was a $30 reduction from 250. And we were told that the $30 represented 12%, which is $30, and that's how we got the 220. And then 220 is in fact 88% of the original price. And if you add 88% and 12%, you get 100%. So just as if you added 220 and 30, you'd get 250. So these problems, if you can think about them enough, you'll see that logically they should stay together. Now, the other thing that we did is we also discussed the idea of how you can view a price change or a quantity change problem. And so the methodology you want to use is you want to have a starting point, which let's call that your base. And then amounts are either going up or they can be going down. If they go up, you get a new amount. If they go down, you get a new amount. Then you can have an amount difference both ways. You can have an amount difference or you can have a percentage difference. So when you have these problems, you're going to be given some combination of these values to find one of the others. But if you can remember that in all of them, whether you're going an increase or a decrease, your base is always going to be your starting point. So let's see if we can apply that to one of these recliner problems. So let's say that we use our recliner problem where we started out with $250, okay, and we reduced it by $20, okay, reduced it by $20. And then the question then was, knowing that you reduced it by $20, what was the percent reduction that you applied to get 250? Well, we determined that the $20 is an 8% reduction, and the new price is $230. And $230 price compared to $250 is what? 92%. So 230 compared to 250 is 92%. So the new price is 92% of the old price. So if you put the original price as 100%, take away 8%, you'd get 92%. Again, if you will make yourself a little diagram like start, it either goes down or goes up, and fill in what you know. Do you know the starting amount? Do you know the amount of the difference or the percentage of the difference? Do you know the new price or the new amount? Fill in what you know, and then it will help you see how you need to solve these. In all cases, your base, whether it goes up or down, your base is going to be where you started. It's going to be the starting dollar amount or the starting value in an increase-decrease problem. And I think I'm going to quit here. How about that?